Okay, so now it comes the fun part. So we have the fascia, we simulated, it was 300 frames, 3 minutes and a half to the simulation. It's really, really fast. I can grab the fascia that we exported, the alembic, and do a new alembic from it, and we can see how it went. So it looks nice, but we have the usual suspects right there. You know, this kind of collision. This happens because of the muscle simulation already has some collision, so the fascia doesn't know who to follow and starts doing weird stuff. You could solve it with some more sub-steps. Sometimes you have to put a lot of sub-steps, so it's really, really slow simulation. And even then, you don't get the nice result that you want. Also, you have that silly thing where you're waiting for a simulation, 8-hour simulation or whatever, and then it went completely wrong. So I really don't like this. I cannot wait. And in production, we shouldn't be waiting that much. So at the end of the day, we have a simulation that is really um, taking days and days and days, and you know the production should go forward. So I will explain a couple of tricks and how I do this, because right now I have this solution, this simulation that I got right here, and I think it's really, really good. It's looking amazingly good, but we just have some issues on the armpits, and that's pretty much it. So let's see how we can just fix some of that. So let's grab these two guys just to get this fascia and turn it into a polygon, so we can do stuff with that. First thing first, first thing that I try also always is a delta mesh. So we can grab our time shift and use that as a reference, you know, reference geometry for the delta mesh, and just this guy. And if we go to one of the problematic, just like this one, well, it, it makes the volume incorrect for sure, but at least we have a nicer topology. But we're doing the delta mesh everywhere. That's not really going to work that much. It really depends on what you're doing. You can just make do with that, and maybe you can just pump up the iterations on the delta mesh, even the step size a little bit, and pin the borders so the borders are at the same place that they were. You can do lots of stuff with that. Now we have something that more or less looks right, but here we have really huge um, um, just hole in, in the geometry going on. So another thing that we can do, we can just grab this fascia without moving at all, and we will get those guys, and this will be, I will do a fascia without simulation, really. So I can duplicate this guy and just do a point deform. And then I will deform this guy using those guys. You know, rest point, first frame, and then you will see that this is without simulation. It is almost real time, as you can see. And it's not perfect, but we have the volumes that we want. And for sure, we can do the same thing right now. Maybe we can change, let me just grab some of these strange things. Maybe it will be a little bit better if we have more. Oh, it's not doing anything. So let's see with less points what happens. It's doing weird stuff, but I'm just looking at the volumes right now, and the volumes look more or less okay. So yeah, that's good. And again, we can do the same thing. We can just duplicate this delta mesh and do a delta mesh right there. So it will keep our um, our fascia clean, and just like the original fascia, which is this one. And you can do the fascia just like that without simulation if you want. That's not really great, but you can get some results that work pretty well. You can see we still have some issues on the armpits there, and I don't know if they are, yeah, they are also here. We can try to do this one as they are the default numbers, and we don't have that much issues there. So now with the delta mesh, we're losing a little bit of the volume, but we have some clean fascia without simulation. This is real time. This is doing just a point deformation, and that's pretty much it. So we can just do another alignment with that to be a little bit faster. So this one is not fascia scene, it's a fascia deform because it's just a point deform. And we will save that to the disk. You will see it's really, really easy. So you can do fascia like that, really. You won't have some sliding and some other complicated things that I will talk in another video, but you will have something. But the idea is that this will be like 20 seconds, 25 seconds, something like that. So in 3 minutes and a half, and then 25 seconds, 4 minutes, I have 300 frames of two fascias to play with. So I can just get a couple of those. I can get my fascia from here. All right. Let's get that one. So you can see this is the one that we did, and this is the one that we did with simulation. Obviously, all these things that are appearing and deforming right there, they are not happening here. Same thing will happen here, I guess, where this, as you can see, this is not really a fascia. This is like, it almost looks like a skin cluster or something. And this looks much, much better how the muscles are moving inside the body thing. So this change of muscles really works. So the only thing that I want right now is to get some of the armpits of this non-simulated fascia to the other one, and we will have everything with. So one thing we can do, fairly simple, is just create an attribute, but I will paint it. Attribute paint. All right, and I will call this mask. Yeah, it's okay. So attribute paint is an amazing tool. Just hit enter and you can paint. Right now it's displaying in an infrared thingy. So when I paint, it's red is 1, blue, purple is 0. You can change that here, as you know. So you can, instead of doing it as a infrared, you can use grayscale. So this is like Maya or whatever you want. I just get used to the infrared and it's working pretty nicely. Also, you can play with volume. So this is a volume. So I'm painting also with this on the other side. You can change it to surface. So even that it's really big, it's not painting on the other side because it just, you can see in the icon that it's just surface paint. So I will reset all changes and I will paint with surface a little bit of that around here, here, yeah, something like that. Maybe here, here. I have my armpits done. Great. And now I can blend those two guys just using this mask. Great. This is called mask. And now we have a point attribute, which is called mask, which is this one. Okay. And you can also, I will not do it because it's a lot of points, but maybe I can just go right there. You can also try to look at that as a marker and you will see the values of each point. Great. As always, this work, but yeah. So let's merge these two. Obviously, they are blade shapeable, so you can do blade shape, but we don't want a blade shape. We want a blade shape with a mask. There's a lot of ways to do that. I prefer to do it with a wrangle, which is your introduction in this series of Bex. which is really, we already did something in Vex with the detailed stuff. This is Vex. This is Vex is like Mel in Maya, is their language of programming. So what we will do is attribute P, which is the position of its point, it's equal to, let's say that it's equal to op input 1P, something like that. That means that now this guy has the P, the position of the points, just right there. So I can see in one of the ugly frames that this guy is no longer this guy, now is this guy. So we want exactly that, but we want to multiply that by a mask. So we will do alert, which is just a multiplication, where the first one will be P. So keep the points that comes from here everywhere, but use this one when mask is 1, or at least multiplied by mask. So now you can see everything is just like this one, not like this one, except the places where I painted the mask. So as you can see, we have done a little bit of work there. Let's do a little bit more here. There's still some places where that didn't work. Yeah, we have, you can see all the muscles right there. They are behaving not like this one, but like this one. But the armpits are using this. So what I'm trying to tell here is that I did that in like 5 minutes, something. I did the simulation in 4 minutes, and I already have a fascia that's really, really good. It's 80% there, and it's doing a lot of stuff that I want. So most of the times when you're working in production, it's much better to do something like that and fix the problems than to try to get a perfect simulation, because there is no such thing. There is no such thing as a perfect simulation. That doesn't exist. So we already have our fascia. Let's try and get some skin simulation or fat simulation next. Okay, so that's it for now. Thank you.